Yeah, hi friends, how are you? A pleasant evening. This is by BS Math Faculty for IIT JEE at Infinity Learn by Sri Chaitanya. Right. So it has been many days we have talked about certain topic, right? So today we are going to talk about, you see, functions related range of a function. You know friends, in a function earlier we talked what a function is and how to find a particular relation whether it is a function or not. After that we defined domain, codomain, range of a function. In the previous class we have seen how to find domain of certain basic functions, right. In this class, my dear friends, we will see how to find the range of the given functions, okay. And you know what a real function is. Before that, let me recall certain important points and definitions related to function, domain, range. Friends, suppose f is a function from a to b, okay. So let me take it as a, this as b, say 1, 2, 3, 4, this is a, b, c, d, e, f are taken. Suppose 1 is mapped to a, 2 to b, 3 to b, 4 to c. Let me call this function as f. Now what is the domain of this function? Undoubtedly a is equal to set 1, 2, 3, 4. This is the domain. What is the codomain of the function? You see, the total set B is called the codomain of the function. Now, what is the range of this function f? Range is set of those elements of the codomain which have pre-images. For example, in this particular set, A has pre-image, B has pre-images, C has pre-image. So this is set of A, B, C, we can call range of this function. It is also denoted by f of capital A, because you can just treat like in the function f, when you give all the elements of A as input, what outputs you are getting is going to form the range. So friends, range is always subset of codomain, isn't it? If DEF are not there, we can say range is equal to codomain. Of course, range is always subset of codomain, sometimes may be equal even. So friends, you have seen what a domain, codomain, range of a function is. The next, friends, what is a real function? Real function means, for a function generally when you take f from a to b, the elements of a and b can be any well defined objects. If we take the function such a way that a subset of r as well as b subset of r, we call such a function is a real variable and real valued function are simply real function. So a real function is that function whose inputs are real numbers, outputs are also real numbers, right? Fine. Now friends, we will be given certain standard questions to find the range of the functions. Let us recall model wise. First question, friends, if you are given f of x is equal to ax plus b, where a is not equal to 0, then what about this function's domain as well as range? Point number 1, friends, since it is a polynomial, domain is very clear, its domain is going to be R, because you can give any real number as input. So domain is R. Now what about the range? Friends, you know the graph of the function may help us to find the range well. You know friends, the graph of a linear expression is a straight line. Suppose a not equal to 0, if a is 0, it is a constant function which is horizontal line. If a not equal to 0, it will be a straight line with some slope, some non-zero slope. If a is positive, the line may be like this with a positive slope. Then you see, you can observe that the values that are covered on y-axis, as the line goes indefinitely, all the values on y-axis are covered. So we can say for this function, range is going to be, yes, R. If a is negative, friends, but still it will be a straight line with negative sloped straight line. So you see on y-axis, if you observe all the values, you just see what are the values that are covered on y-axis to the corresponding curve. Every value is covered. So I can say that by just observing the graph, the range of any linear polynomial is R, provided x coefficient should not be 0. Friends, at the same time, what happens if a is 0, f of x is b, which is a constant function? In that case, the graph will be a horizontal line. For every input, the output is just a single number. So in that case, range is, for example, f of x is b, you will get only one number b as output. Right, friends? So in a nutshell, what I can say is, point number 1, if the function f of x is equal to ax plus b is given, for this domain is very clear, domain is R, range is, yeah. Now can you say, friends, if a not equal to 0, the range is R. If a is 0, it is just a singleton set if a is equal to 0. So this is point number 1, friends. Clear? So model 2. Suppose, friends, you are given a cubic polynomial. F of x is like, say, ax cube plus bx square plus cx plus d. Of course, a, b, c, d are real numbers. A not equal to 0, because I said it is cubic polynomial, right? For any cubic polynomial, of course, any odd degree polynomial, suppose if a is positive, you know, the graph of any polynomial will be continuous and smooth curve. Second thing, if a is positive, as x tends to infinity, it must go to infinity. As x tends to minus infinity, it must go to minus infinity. Based on this, it may take two turnings or one turning or something. But one thing is clear, as x tends to minus infinity, it goes to minus infinity, here plus infinity. So you see, with this, what are the values that are covered on y-axis? Can you guess? You see, you just observe the curve, every value on y-axis is covered. So we can say the range is R. If a is negative even, the curve may be like this, but still all real values on y-axis are covered. So the range is going to be R. So friends, the important observation here is, yeah, second point, most important one, if f of x is any odd degree polynomial, maybe cubic, maybe degree 5, then you can clearly say that domain is anyhow R, even range is also R. This is the second important point. Of course, I need to go to quadratic. Before I go to quadratic, let me cover few problems, then go to quadratic, right? Fine. The third point, friends, suppose f of x is given like, you see 3x plus 4 by 7x minus 5, something is given like this, like ax plus b by cx plus d. What about its range? Yeah, before I go to range, let me talk about domain, friends. What is the domain of this function? As we have talked in the last class, the denominator should not be 0. So, this should not be 0. So, the domain must be all real numbers except 5 by 7, all real numbers except 5 by 7. Okay. Next, what about the range? How to find the range of this? Of course, we can draw the graph, which is little difficult comparative to previous one, but what I say is, you see, to find the range I adopt the mechanism here. You see, friends, 3x plus 4 by 7x minus 5, suppose the output value is y. Range means set of all outputs. Suppose the output possible value is y. From this, anyhow I have taken x such that denominator not equal to 0, you will get 3x plus 4 is 7xy minus 5y. From this you simplify such that x is equal to, you see, 7xy minus 3x is equal to 4 plus 5y. From this you bring x is equal to 4 plus 5y by 7y minus 3. Yes. Friends, what does it mean? Generally here we give real numbers for x, we expect real numbers as y outside. So, here x is real means y can be any real number except y is 3 by 7. That means whatever output you want y, suppose if I want y is equal to 1, you put y is equal to 1 here, 9 by 4. If you give 9 by 4 is the input, you will get output as 1. So, whatever output you want as y, our x is ready, but I can't get y is equal to 3 by 7 because corresponding to that x is not available. So, friends, y cannot be 3 by 7 for real x. So, range of this function means, do remember, for this function range means you will get every real number as output except 3 by 7, except 3 by 7. Yes, this is the range. Fine. Domain as well as range. Clear? Let me generalize this, friends. Suppose extension to the same problem, third model discussion. If f of x is given like ax plus b by cx plus d, linear expression by linear expression, do remember its domain is, yes, R except minus d by c, yes, and its range is going to be, friends, you can observe all real numbers except a by c. Try to remember this shortcut, you can remember. You see, in the previous problem you just got 3 by 7, this is 3 is nothing but x coefficient, 7 is nothing but here x coefficient. So, the range of this function, whenever such question is given, you no need to compute again, you can directly answer that the range is r minus 3 by 7, which is important, you try to remember as a shortcut. So, friends, for this f of x, domain is this, range is this. Okay? This is the third model. Model 1, friends, if f of x is a linear expression, if a not equal to 0, range is R, if a is 0, range is a singleton set. For any odd degree polynomial, range is R. Then if f of x is given like linear by linear, domain is anyhow you can do, range is R minus of 3 by 7 kind of a by c. This is one model. Next, friends, fourth model, range of a quadratic expression. You see, friends, if you are given y is equal to ax square plus bx plus c kind of, without any restriction on x, what you can do is, friends, you just observe whether A is positive or not. Second, A negative. You know that if A is positive, this expression will be upper parabola. You see the turning point, you know, minus b by 2a, and this is 4ac minus b square by 4a. So, the range is, friends, minimum is here 4ac minus b square by 4a, maximum is infinity. Whereas, friends, if A is negative, it is a down parabola. So, maximum is this, minimum is minus infinity. This is the range. So, in this case, minus infinity to 4ac minus b square by 4a, you can apply the shortcut directly to get the range. Otherwise, again we need to take the derivative, we need to find the turning point, calculating and all these things. Rather, if you want the range of any quadratic expression, you can simply use this technique. Suppose, friends, you are given find the range of y is equal to x square plus x plus 1 is the first question. Second question, y is equal to x square plus x plus 1 when x is minus 1 less than or equal to x less than or equal to 2. Third question, if y is equal to x square plus x plus 1 when this is 2 less than or equal to x less than or equal to 3. So, there are 3 questions. It is a direct quadratic expression, no restriction on x, whereas here x is restricted. How to do in this case, friends? You see, the first case is very clear. Yeah, right. The first case is very clear. It's a direct question. The range, it is upper parabola, minimum value 4ac minus b square. Friends, I think let me write the formula for your convenience. B square by 4a to infinity, which is, friends, if you compute 4ac minus b square 3 by 4 to infinity, this is the range. Whereas, friends, the second case x is restricted, the shortcut, actually you won't get the total parabola. Here you will get some part of the parabola. My suggestion in this case, to find the range of a restricted quadratic expression, I am going to give a beautiful shortcut, friends. You just check minus b by 2a, which is minus 1 by 2. Does it belong to this or not? Does it belong to the restricted region or not? Yes, belongs to. If belongs to, that means the graph would be some part of the parabola including turning point. So, in that case, friends, you just need to take the extremes f of minus 1, f of 2, 4ac minus b square by 4a. You consider these 3 numbers. Of those 3, smaller is the minimum, greater is the maximum. If you just consider f of minus 1, what is f of minus 1? 1. What is f of 2? 7. What is 4ac minus b square by 4a, which is 3 by 4. Now you tell me the least value is 3 by 4, highest value is 7. So, friends, I can say in this case the range is least value 3 by 4, greatest value 7. You can say the range in this way, my dear friends. Third one is also the same quadratic expression, but this is the restricted area. You just find minus b by 2a, which is minus 1 by 2, but it doesn't belong to this. Doesn't belong means you have taken part of the parabola in which turning is not there. That means the graph may be like this. So, undoubtedly at one end it will have minimum, the other end it will have maximum. So, you simply find f of 2 as well as f of 3 you find. You don't try to take 4ac minus b square by 4a because turning point is not included in the journey. What is f of 2? 7, f of 3, 13. So minimum value is 7, maximum is 13. So for the third question friends, minimum is 7, maximum is 13, right? So friends, yeah, so this is kind of finding range of a quadratic expression restricted case. In extensions to this, you may be given an expression like, you see, y is equal to 3 sin power 4x minus 2 sin square x plus 7 is given. Find the range of this expression. Of course, it is trigonometric, but indirectly it is like quadratic. You see, you can treat it as 3t square minus 2t plus 7, where t is equal to sin square x, where sin square x in the sense it belongs to closed 0 to 1. Sin square x belongs to closed 0 to 1 because, yeah, right. So friends, if you put sin x is 0, you will get 7. If you put sin x is 1, 10 minus 2, 8. So closed 7 to 8 is the range. So first of all friends, before that you just check whether I am correct or wrong. You see, indirectly it is a restricted quadratic expression, yeah. So I mean to say, when you handle a restricted quadratic expression, what to do? So you just check minus b by 2a, which is minus b is 2 by 2a, minus b by 2a, which is 1 by 3, it belongs to this. When it belongs to this, you need to take three things. One is f of 0, which is 7, f of 1 means 8, 4ac minus b square by 4a, 4ac minus b square by 4a, which is friends set of 7, 8, you can take 4 common, 20 by 3, 20 by 3. Undoubtedly the minimum value is 20 by 3, maximum value is 8. So friends, the range is 20 by 3 to 8, that's all. So the quadratic expression range is important, of which a direct question, restricted quadratic expression in which the turning includes, a restricted quadratic expression in which turning is not there, and indirectly given question. So we can say this is one set of important models regarding range. Friends, even seventh one, I can say f of x is, you are given like a cos x plus b sin x plus c. What could be the range of this particular expression? You see, for this expression, the minimum value you know well, c minus root of a square plus b square, maximum value is c plus root of a square plus b square. Moreover, it is a continuous function, so the range lies between this to this. Yes. The logic is simple. You can take f of x as, you see, c plus, you just multiply and divide with a square plus b square into a by root of a square plus b square cos x plus b by root of a square plus b square sin x. Friends, so now this is c plus root of a square plus b square. These are two numbers such that sum of their squares is 1. So there exists some constant theta such that one is sin theta, other is cos theta. So suppose this is sin theta, this is cos theta. So now it is like sin a cos b plus cos a sin b. So you can write sin of theta plus x. For unrestricted x, its maximum value is 1. So, this becomes c plus root of a square plus b square. Its minimum value is minus 1. In that case, it becomes c minus root of a square plus b square. This is one important model, friends, where we can see the minimum and maximum values of this function. Okay. And apart from this, friends, I can say you consider the function like f of x is x square plus x plus 1 by x square minus x plus 1. Yes. What could be the range of such expressions? Of course, friends, we find the range of such expressions by taking it is equal to y. We prepare a quadratic equation in x. Since x is real, we apply, you see, prepare a quadratic equation in x. Since x is real, apply delta greater than or equal to 0. You will get quadratic inequation in terms of y, where you will get y belongs to 1 by 3 to 3. Rather, friends, if you are given a function like f of x is equal to ax square plus bx plus c by ax square minus bx plus c, or maybe here minus here plus. In this case, we have a shortcut to find the range, friends. F of plus or minus root of c by a will give you range. Yes, which is, friends, f of plus or minus, in this particular case c is 1, a is 1. So, f of plus or minus 1 you take. So, it gives f of 1 is going to be 3, f of minus 1 is going to be 1 by 3. So, the range of this quadratic expression is 1 by 3 to 3. If the problem is given in this way, in this pattern, then only the shortcut works. Otherwise, you need to go for the procedure. What is the procedure? Especially when quadratic by quadratic is given, let it be equal to y, prepare a quadratic equation in x and take, since x is real number, apply delta greater than or equal to 0, because the x coefficients will be in terms of y. So, you will get quadratic inequation in y, you solve it, you will get the range of y. In this way, we can see n number of problems, right, friends. So, apart from this, you can take y is equal to say mod x minus 1 plus mod x minus 5 kind of expression is given. I think you know the graph of this particular expression is very simple and easy. It turns at 1, for this significant number is 5. At 1 it is going to be 4, at 5 also it is going to be 4. You just take the cases, you will get the graph like a tub. In this case, friends, the minimum value is going to be 4, maximum goes to infinity. So, friends, the range is closed 4 to infinity, like especially if it is like mod x minus a plus mod x minus b, the minimum value is going to be, you see, mod a minus b is the minimum value, maximum value is infinity. You can observe a shortcut even, right. In this way you can do. Even the 10th one, if you are given like f of x is mod x minus 1 plus mod x minus 3 plus mod x minus 11, suppose sum of 3 simple moduli are given, you just observe that its graph is significant at 1, then 3, then 11. At 1 you can see this is 10 plus 2, which is 12. At 3 you can observe that this is 2 plus 8, which is 10. At 11 you will get 10 plus see 8, 18 somewhere here. If you join the graph, it will be like this, friends, like this. Undoubtedly, this is the sum of deviations of the numbers taken from 1, 2, 3 will be minimum at the median. So 1, 3, 11, median is 3. So the minimum value is 10, maximum goes to infinity. So friend, the range is going to be closer to 10 to infinity. So this problem can be answered very easily when you plot the 1 less than 3 less than 11, median is 3, you can find the minimum value at 3. So friends, in this way we try to find the range of exclusive linear expression. Yeah. 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 Right. So in the previous, in this class we have seen how to find the range of linear expression, polynomial expression with odd degree, quadratic expression, restricted quadratic expression, linear by linear case, quadratic by quadratic case, modulus combinations, all these things we have seen. Right, dear students? Hope you have enjoyed the session and stay tuned to Infinity Learn for upcoming classes.